Okay, today we are going to take the second derivative of an implicit function, of a function that's not explicitly written as y as a function of x. So basically, let's get that down while you get yourself sorted out with your notes. So we're going to find find the second derivative of let's just say find the second derivative implicitly. So let's just talk about a couple of things. So the function I'm going to give you, let me just give it to you right now. Given x squared plus y squared is equal to 49, I want you to find d2y over dx squared. So find the second derivative of that. Now, I will tell you, for the purpose of lecture, instead of making it like a little bit larger that I do realize you could find two different functions to write that as you could write it as 49 minus x squared, the square root of 49 minus x squared, and negative square root of 49 minus x squared. That could be written, and you could take the second derivative appropriately, and then except for the endpoint, wherever it's differentiable. But for the purpose of the lecture, we'll do it all just as it stands, and we'll take the second derivative. So let's just go ahead and use yesterday to take the first derivative. So nice and easy. Let's remind us, all variables y are actually holders. They're a composite function. The function is with respect to x, and it's a y. So all the y's require the chain rule. So they're all going to be followed with dy dx. So as we march forward, take the derivative of the first as normal. Remember, the variables agree. I'm taking the derivative of x squared with respect to x. So it agrees. So 2x. Derivative of y is 2y. Y is not x. Needs to be followed by the chain rule. dy dx. Take the derivative of the right-hand side. Derivative of the right-hand side is 0. Times dy dx. 0. Let's just get everything away from the dy dx and solve for it. So that's going to be a negative 2x over negative 2y. No, over a positive 2y. I'm so sorry. Dy dx. Right now. You and I can see we're going to cancel out those twos, and we're with the first derivative. Nice and easy. Negative x over y. Okay, we're done with the first derivative. So as we've done, when you want to find the second derivative, you find the derivative of the derivative. So let's go in and do that. So now we are. So now we're doing, now is where it's different than yesterday. So now we're going to take the derivative of that. So when I take the derivative of dy dx, when I take the derivative of the derivative, that is d2y dx squared. That is the second derivative. Now let's use the quotient rule. So derivative of the numerator is negative 1 times the denominator minus derivative, leave the numerator, times the derivative of the denominator. The derivative of the denominator is 1 dy dx. So dy dx all over low, so y squared. So now, I mean, you're done, But now it's just going to be a cleanup. That's what's inherently in this second derivative business. There's just a bunch of cleanup to do. So let's get used to doing it. So look what I have. In my second derivative, I have my first derivative. So we're going to have to go re-plug that back in and solve for it. So let's go ahead and plug that in. So d2y dx squared is equal to negative y. And hopefully you're okay with me making that minus a plus there, right? So that becomes plus x times dy dx. And dy dx is negative x over y. Let's plug that in. So x times negative x over y. So I just replaced my dy dx all over y squared. Okay, so that looks a bit of a mess, doesn't it? A fraction in the numerator. We're going to go ahead and flatten those fractions. So let's just do this. Let's multiply top and bottom by y. Right, clear that out. So that's going to be all that nonsense right there. So let's go do that. So d2y dx squared is equal to, so I'm going to do a negative y times my y gets me my negative y squared. Then I multiply this term right here by my y gets me negative x squared. Flattened fraction all over y cubed. Okay, are we there? Actually, what was the original equation? Actually, look. Right there. Look at our original equation. X squared plus y squared is 49. And look what's in our second derivative. Negative y squared minus x squared. Or how about I do this? How about negative x squared minus y squared? Maybe that'll be easier for you to see it. Right? So negative x squared minus y squared, well, that's almost like x squared plus y squared. So why don't I just do something over here with this green and maybe you can see it. X squared plus y squared is 49 is the same thing as saying negative x squared plus y squared is equal to negative 49. Or negative x squared plus or negative x squared minus x squared. I'll try that again. Sorry about that. Negative x squared minus y squared is equal to negative 49. Look at this. Boom. Right there. I have that. So let's go down and put that right here. Or there. That's where I'd cleaned it up, hadn't I? So then let's just go ahead and do that. So your final answer. What did I say negative x squared minus y squared was? Negative 49. I don't want to pull the page down again. I'm pretty sure it was. There's your second derivative. Final answer. Okay. Fairly easy. You're going to be doing that. You're going to be doing 3 problems. I put them up on the board. I'll put them on this video right here. You're going to be doing page 147. And you're going to do a couple practice. You're going to do 39, 45, and 49. So the first one is going to just be a warm-up. It's kind of yesterday, first derivative, but the numbers are a little harder. Then you're going to do second derivative with these guys, practicing that whole thing and cleaning up. This one, 39, I'm also going to make you find the equation of the tangent line. So some good practice there. So you'll actually plug points in and find the slope at the particular point. And it'll be a bit messier than it was before. And there's going to be an algebraic cleanup situation that it's just going to be a bit for you to think about. Okay. So, but calculus is easy if you're algebra and trig are good. So you'll be fine. Okay. I'll take questions here in a minute. I'll stop this for us.